Okay. All right. Great.
Okay, so if you guys are good, let me go ahead then and get back into basically where we left off, right? Which is making sure that we understand what's going on in chapters 3 and 4. What I'd like you to do, guys, is yell at me, say something if there's something that you want to discuss. So, first thing is this. Let's make sure that we're clear on the basics of using Bool and using Bool to evaluate sentences. So suppose that I have the following, and I'll just use our blocks language. Suppose that I have the following two sentences, right? You know, and I know that Tarski's world will not allow you to make a sentence in which A is both a cube and a tet, right? It's not possible to make the one object be simultaneously two sizes. But we know that the truth table is not at all sensitive to semantics, right? So it doesn't understand what it is to say that A could be both a cube and a tet. Hence, I've just gone ahead and auto-filled. You can click this button or you can go under table to autofill. Notice that on row 1, we have what is in Tarski's world an impossibility, right? So this gives us an idea, right? Remember that the truth table understands only what it is for connectives to operate on atomic sentences or on already compounded sentences. So before moving on, and by the way, forgive me because as folks come on in to the meeting, because the screen I'm currently using is small, I can't see everybody, but I promise I'm getting a big screen. So here's who I see right now. I see Eric and Dereje and Peter and Evan and Deb and Lewis and Farzam and Evan. So don't forget, guys, if you have a question, just, speak up. Okay, so now I'm going to make the following sentence. I'm going to say A is a tet, but it's not a cube. Right, so I'm not going to, right now I'm not going to violate the Tarski's world constraints where I'm making a sentence that is possibly true on a truth table, but could never be true in Tarski's world. So as a reminder, we have to, when we have multiple connectives, we have to determine our main connective, and then we determine the possible values for that main connective by, if you will, calculating or building up to it, starting from our atomic values. So one of the nice things that Bool does for us is this. If you click in the column under the negation, suppose that you erroneously think the negation is the main connective, so you click in the column, what Bool does for us is says, hey guys, by way of the green highlight, this is the value that you need to consult in order to make sense of this negation, right? On the other hand, if you click under the conjunction, you see that the conjunction is the main connective because it refers to the left side of the conjunction. So it refers to the left conjunct, which happens to be the atomic sentence A is a tet, and it refers to the negation of the atomic sentence A is a cube. So those green highlights are helpful to reminding us what we need to do first. We know that the negations truth definitions are as follows. The negations truth value is defined by the meaning of the negation and the original value or the value of the sentence it negates. So it's not the case that true is false, not the case that false is true, not the case that true is false, not the case that false is true. And does everybody remember also that the way we set up on the board our truth tables, yes, we can have the reference column like we have in Bool, but we can also put our atomic sentence values directly beneath the atomic sentence in the compound statement. Bool doesn't let us do that, right? So, I could, if I want, go ahead and remind myself, right, like this, but of course my writing is using the annotator's crapola, right? I could do that if I want. And that might be useful for sentences that are really complicated when it's hard for me to, or really complicated in the sense that there are lots and lots and lots of rows. I might lose sight of where my references are. But just know that Bool is never going to put the values directly under the atomic sentence in the compound element. Okay. So again, yell out if there's something that I'm doing that doesn't make sense. Now we're ready to work our conjunction values. We know that a conjunction is true if and only if each of the conjuncts is true, right? So we get the following. We get false, true, false, false. Now, if you want to make sure that you've done everything right, Bool gives us some great feedback. We can verify with our check mark, an X button. Now we're in a position to work our assessments. So notice, because these guys are grayed out, we can't make any evaluation. And we can't make any evaluation because the two grayed out sets of evaluation concepts are concepts that apply to multiple sentences. We just have one right now. So the question is this sentence always true? No, it's not always true. Is the sentence possible? In other words, is there a world in which this sentence could obtain, it could play out? Yes, it is. Is this sentence always false? No, it's not. Before moving on, let's talk about why it is not a tautology. When you look in the column under, in this case, the main connective, you have at least one false value. A tautology is a sentence that is always true. That is, it's true on every row in the column under the main connective. This sentence is possibly true, right? It's truth table possible because there is one row where the sentence comes out true. And remember, hold on just one second. Remember, we're not at all interested in the sub-values, right? So we're interested only in the value of the sentence as a whole, that is the conjunction sentence. And then lastly, and what this concept is going to come up for us in an important way when we get to chapter 6. I don't make a big stink about it in our work here in chapter 4, at least not on the in-class exam, because you're juggling a lot of concepts right now. And sometimes the notion of a contradiction is a little bit off-putting. You definitely do get to it in chapter 6. So it's not contradictory, or if you will, self-contradictory, because it's not false on every row. Okay? So I'm going to click OK, and now I'm going to find out if I'm right in my assessments. Wait a minute, what happened? What's wrong? Well, strictly speaking, right, nothing's wrong. I just took my values away from the negation. So let me go back and fill those. Oh, wait, what did I do? Yeah, sorry. Okay. So do you see the check mark in green next to the assessment? The sentence is not a tautology. There is one row that shows the sentence could be true. In fact, it is true on row 2 if row 2 is a world that obtains, and it's also not contradictory. Thoughts?
Could you repeat that?
Yes. The sentence is not a tautology because there is at least one row where the sentence is false. In other words, we don't have true on every row of the truth table in the column under the main connective. The sentence is possibly true. It's a truth table possible sentence because it's true at least once. So let's say, pop back into Tarski's world really quickly. We can build a world in which A is a tet, not a cube. Finally, the sentence is not self-contradictory because it doesn't have F's, right, on every row of the truth table in the column under the main connective. In other words, it's true in one possible case, so it's not always false. It's false a lot of the time, but not always.